Hey guys, what's up? Eddie Yahoo here with kissanalog.com, and we have Uni-T in the lab. This is a really cool scope. Yeah, these 12-bit scopes are just getting better and better. I'm going to come over, open up the box real quick. I'm going to then show you some measurements and show you some features and just kind of show you what it does, okay? Talk about the specs at the same time, showing you how it works. Hopefully you like this format. Let me know. Comments below. And if you've seen this scope, because it's pretty darn new. So, all right, guys. And by the way, we'll go over the prices and the options for this later. But let's just jump into this. Come over, bench, take a look. And by the way, today's Thanksgiving. So my wife's in London. So I'm kind of on my own. I'm going to my family's, and we're going to do a Thanksgiving thing she made. So I'm looking at my watch because I got enough time to start this video. I'll finish up tonight, hopefully, and probably post this the day after Thanksgiving. We'll see. All right. All right. Let's come over here and look in the box. All right. So what we have is a UPO1152HD. So 1152 HD for high def. All right. It's kind of a small box, right? All right. This is pretty cool. Now, it looks like there's a manual or something back here. It's probably the calibration certificate. We'll figure out. I guess I got to slide it out back here. Pull that out. I'm going to pull the scope out. Here's a power cord, 2 probes, so it's a 2-channel scope. Here's a grounding thing that I might not ever use. And here's our USB-C power. No, this is just USB for communications. So hold on a sec. Oh, here we go. Here's the adapter with the USB-C. Okay, so yeah, of course the power plug fits into that. Okay, I'll pull this out and show it to you. Yes, it was a certificate of calibration back in there. Kind of shows you what they used to do it. The power cord, the ground wire, all the things I just showed you, I guess. That's the packing list. Okay, and there is a nice scope. Let's get that powered up. Well, actually, before I do that, let me just show you what it looks like all the way around. Okay, we got vents on the side for cooling, vents on the back, vents on the bottom, and there's a little hand grip. So we have USB, so we can talk SEPI, I think it is, and then Ethernet. There's our USB-C input for power, and there's a leg. There's our little legs that pop out, rubberized on the bottom, and big rubber feet here. And here's some mounting points, so we can mount it on a wall or something, I guess. So yeah, that's on both sides. Okay, on the front we get USB-C power. We get USB power for probes and such, and a soft power button. So is there a power button back here? I suppose once you plug it in, it's just soft power. Oh, there's the grounding leg right here. Okay. So flip it back over. 2 probes. Here's our compensation. And there are the controls. So imagine all these buttons have a push feature, which they feel like they do. They have indents. Well, this knob has indent. This one feels smooth. Yeah, indents, and indents, or detents, or which way is it? Detents or indents? Detents probably. And that one's smooth. Okay, so that's that set up. Now here's the screen cover on this thing. You know, I'm not sure if this is a loaner or if they sent it to me for keepers. So I'm not sure if I should peel that off. So I'm going to leave it on for now. All right, guys, let's go ahead and power it up. Okay, get some green lights. I'm wondering, yeah, it's going to show us the light shows, so you can, I think it's kind of a self-test, but it also gives us a chance to make sure that all the lights are working and everything's working. Okay, the R12. Now, some people are concerned with how much time you know, they like to time the power up sequence, but that part has never really concerned me much because you want a scope to warm up, and I usually turn them on, let them run for a bit before I start using them. But anyway, this looks like it took about the typical amount of time, but man, look at that. That is nice. Okay, so what should we do first? Okay, so inside the box, underneath the probes, I found these two things. Safety precautions, that is pretty thick. It's kind of laughable, actually. It's thicker than the quick start guide. Well, you know, safety's very important, right? And so, yeah, look how thick that thing is. So, but yeah, this is a quick start guide. We'll take a look at this. Maybe I'll show you some pages as we go ahead, okay? But right up front here, there's some codes to scan in so you get your firmware updates and manuals and all that kind of stuff, okay? All right, I'm going to try to put the scope there, and we're going to go through some cool features and functions and stuff like that, talk about the specs. And right behind it is the big brother, the MSO3054HD. So this is a 500 megahertz, 2.5 gigasample 12-bit. This is 150 megahertz, 1.25 gigasamples, 12-bit. Yeah, this is pretty sweet. And it's a 7-inch screen. All right, guys, so right out of the gate, I just want to talk about the feel of it. It feels really nice. You know, when you pick up an instrument, it just feels like it's made well. This thing, you know, nice and flat. I like these flat scopes, fit, you know, on a smaller bench. Like, a lot of benches aren't that deep, right? And so, anyway, it's nice that without the big CRTs, we're starting to get the scopes into a smaller format now. Now, also, I really like the new thing we're doing USB-C. So now, this thing is isolated from my power strip, from my AC power. So there's a first step in safety right there, isolation. So now I've got safety isolation, but also probably noise isolation too, because now I got DC power coming into the scope. So now I don't have to worry about shielding and all those things with AC power cords. So I really like that kind of movement as well. My MixSig scope, where's that? You know, they've been powered that way for a while, plus they have battery. That'd be the next thing, is to offer one of these with maybe slightly thicker thing with maybe a battery, so you could take this and a battery. That'd be cool. Uni-T, battery operated version of a scope in this line, I think. The UPO1100. Now they have the 2000 series as well, and then they have this 3000 series. So they've got different series. So we're gonna wait to talk about the different models here and the prices, but I think you're gonna be impressed with that. So let's go ahead and compensate the probes. When you first get a scope, that's one of the first things you want to do. You want to let it run for a while, let it warm up and all that kind of stuff, and then compensate them. Now, one thing I found in recent scopes is it feels like they're already compensated. I've had to make minor adjustments. I don't even think I had to. I just did, just because I felt like I needed to do something. So I adjusted and adjusted right back to where it was. That's what it seemed like. What do you guys? Let me know in the comments below if I've just been lucky with some of these scopes, or maybe somebody else already compensated before they sent them out. I don't know. Maybe the components and the probes and the, because what you're doing is there's the capacitance and there's the components inside the probe that you're trying to compensate or pair up with those capacitors and inductances or resistances inside the scope, right? You're trying to match them up is what you're doing. So yeah, maybe they do it before they send them out. I doubt it. Might be just that the components they're using are spec'd out tighter tolerances. I'm not sure. Or I just got lucky. Anyway, leave in comments. I'm talking too much. Let's get into the next. Let's compensate this thing. All right. So I had the two probes in. They already have the color rings on them. Okay. So that way, see, there's the blue one. It's on both ends, so it's easy to track where your probes are connected. And right now I just have the red one on the compensation. And already, and I just want to show you, that's how it came up, because just straight out of the box, right? And I can already see it needs to be compensated. All right, so I'm going to hit this auto set button right here, and let's see what it does for auto set. All right, there you go. So it put the cursor, see the arrow right here in the middle of the screen. So it's going there. So if I wanted to get a full scale, a bigger, you know, picture of that, then I could bring this down here somewhere. And now, hey guys, by the way, make sure this is in times 10. Watch, I'm going to switch this other probe to times 1. And by the way, I really like these probes. These probes, it's nice and stiff. The thing goes in place. I had a oscilloscope that it was just so loose. I always had to get in the habit of just pushing it forward every time I used it. But you see how square it is? That's because in times 1, the RC components inside the probe, they go essentially to 0. Your bandwidth is really limited in times 1. That's why you want to be in times 10 for most probing, okay? Always going times 10. Just want to tell you that, okay? I've seen some people, some experienced technicians, that use times 1 often, and you almost never want to be in times 1, okay? All right, so let me know what you guys think about that, but that's the way I look at it. Okay, so I can expand it this way, and the top part will go off, and that's okay. I can compensate just on the bottom. So as a matter of fact, I didn't even need to move it. I could just left right here in the middle of the screen as far as that goes, and I can keep on doing that. And so now it's going to be really easy to focus on getting that square, right? Now, I want to set some things up since this is the first time we're using the scope. And I'm trying to turn off some lights so we don't get glare, by the way. So here, let's go to some menu stuff. Go to here, and where's display? There's display. I want to turn up the grid a little bit just for the camera to make it easier for you to see maybe. Let me know if that makes it any easier. I'm going to turn up the wave brightness, the backlight. What are we going to do on that? It just gets real bright. Does that, I don't know, maybe I'll turn them all up a little bit. And transparency, that's, you know, that's some of these boxes that how transparent they are when they're on the screen. So I'll just put them right there for now. And here's the color. So we can have color displays if we want. Okay, I'm going to turn that off for now. And so I want to do that. All right, so that just sets up the display. So let's just use that for now. So maybe it's easier for you to see this. Okay, now let me get the little screwdriver. Okay, so after auto set, I get this little curve. I can see that. But you know, remember, so you set that probe to 10x, but then you have to come in here and make sure your scope knows that because it doesn't have an identifier on the probe tip, so you have to come in here. Now I can hit the down menu. Oops, let's see if I can get my fat fingers on that. And I can just choose 10x. You can double bump it and then put in whatever you want. But, okay, so now I got 10x full bandwidth, okay? Now, just for fun, let's go to 20 meg limit. So I still get my theme, but it rounded it off a little bit. So let's go to full bandwidth. So 10x DC, volts, and yeah, so that's the way I want it set up, okay? Displays on, inverts off, finds off, scale, 1 volt per division at this point, okay? So there I am, 1 volt per division, okay? So now I come in here and I bring this up, and if I go too far, see it goes the other way? So if I bring it down where it looks nice and square, I can kind of tell that it's rounded a little bit, but it looks pretty square. Okay, if I go a little bit more, that looks a little more square. Okay, but if I zoom in, like 200 millivolts per division, 100 millivolts per division, look at that. It's got a little bit of a slope. So you got to come in here and I'll tell you what, you're going to end up with a little bit of a dip and then it comes up. So it's a little bit of a overshoot, and you almost need that little bit of overshoot to get the rest of it square. Okay. Then if I go back to the 1 volt, whoops. Okay, there's 1 volt. you can see that little overshoot. So that might bother you. So you have to kind of decide like how much, because if you capture a waveform, you zoom in, you know, it's not going to be perfect, right? It's going to, now every probe's a little bit different. So if you go, well, okay, I'm going to look at it about there. Okay. That's about right. And so, okay, so let's go back to the 1 volt. And remember, you're going to have that little bit of an undershoot and overshoot. So to me, I know the edges are going to have a little bit of an overshoot if I set this up, or I can undercompensate it. I think that's called undercompensate, where it's a little bit rounded, or is it overcompensate? I always forget which one's which. But anyway, let me know in the comments which one it is. Okay, so if I go all the way to 100 millivolts, I can see it's like that. But if I come down half a volt, well, even a half a volt, okay? So, yeah, I don't know. I just kind of want it as flat as I can, even though if I get a little bit of a under and overshoot, that looks pretty square, half a volt, 200 millivolts, still looks pretty good. If I really zoom in, I'm going to start getting, yeah. So I think that looks pretty good. So that's what I kind of recommend doing. Now here, let me show you something else. This is a cool scope because some scopes do this. I think more scopes are doing this now, where I can trigger on both edges, okay? So that was a positive edge where I did before. There's a negative edge. But if I do both edges, I should get pretty much a straight line across here. And I pretty much do. I get that little bit of a bump right there. And this is a half a volt per division, right? So if I do the auto set thing, it's going to look a little bit like that, okay? So there you go. Let me know how you guys compensate it. But the probes don't, don't always give you a perfect square wave. Okay, so yeah, that's it. Now, and by the way, you want to color code them to the channel because you're kind of pairing it up with the input channel, and each input channel might be slightly different. Each probe might be slightly different. So yeah, so now we'll go to channel 2 and we'll do that one and turn this guy off, and then we'll come over here and trigger on channel 2. And then I'll rotate this around so I can get to the window. And I'm going to do the same thing. So I won't bore you with this. Let's move on. All right, so compensation. Yeah, make sure that probe is in times 10 pretty much all the time you're using it, especially when you're compensating. Switching to times 1, you can't compensate it. So, all right, so let's move on. All right, so what I want to show you is how to use that deep memory, okay? I mean, these scopes, especially Uni-T, is just kicking butt with the deep memory. So, yeah, the other 12-bit scopes came out before it. This one is giving it a run for the money. Let's check it out. All right, guys, so I have both channels on. They're both on compensation. I just hit auto set, and it set it up like that. My trigger is on channel 2, but here, I'm going to switch it to, oh, no, it's on channel 1. You know, I wish I'd color code it for which channel, like yellow, make that marker yellow, so I don't have to look down here and see, just because it'd be easier for me. But yeah, anyway, so if I go to channel 2 or channel 1, it's the same blue trigger, but no biggie. I've noticed I have different scopes, and I just think that'd be a cool feature of no extra software. But all right, so let's move on. What I want to show you is deep memory, okay? So let's zoom it in so you get a bunch of waveforms. So maybe we're looking at ripple like that. Maybe that square wave is high frequency switching ripple, but then I want to see if there's any low frequency ripple. So I zoom out like this, and I'm catching lots of waveforms, right? And then it goes in roll mode if I go too much time. Okay, so then I freeze it. I go, well, let's zoom in. I think I saw something there. You go, oh, it wasn't there. It was over here. And I go over here, and I can zoom in on these particular wave shapes, and I can really see, you know, what's going on, right? And so I can zoom way in. And so, look, you can still see a little here. Let me push this center up. You can still see a little bit of ringing. It's not digitized, what I call, where it's like stair-steppy. You can almost see, if you look super close, you can almost see a little stair-steppy thing. Here, I'll zoom in like that. Look at that. It's sinusoidal, but I see a little bit of a stair-steppy thing in there. But man, that is crazy that I get all those waveforms and I can zoom in on an edge like this. We're at 1 microsecond per division right now, and I can get that kind of resolution. So that's deep memory, okay? Look at that. That's just crazy. Okay, so I bring the waveforms back in, and if I trying to go back to where I was, I go, oh, okay, I captured that much data. So that was at 50 milliseconds, and I went to 1 microsecond. So that is ridiculous. Now, by the way, it gets better. Right now I'm at 5 megapoints per division. Okay, here, let's run this. See, 5 megapoints, or 5 megapoint sampling is what I'm getting. So here, let's click on that. And it says normal, auto, depth, sync, and linear. So if I go to auto, okay, it's set it at 5 meg, which is kind of the minimum. So that way the scope runs real fast and all that. But what if I go to 100 meg? That's maximum, 100 meg points. That's crazy. But look, I got both channels on. How'd that happen? It's because I get 100 meg on 2 channels. I don't divide in 2 when I go to a second channel. So check your scope. See if it does that. A lot of times when they're quoting that deep memory, it's with 1 channel. When you turn on 2 channels, it drops in half. And then if you go to 3 or 4 channels, it drops again in half. But anyway, I just wanted to point that out. You get 100 meg with 2 channels running. Okay, so now we're running. Now let's stop that again. Let's go back to that 1 microsecond thing. Zooming in, zooming in. Okay, there's 1 microsecond. Look at that. It smoothed everything right out. So was that, not real, what we were seeing before? What was going on there? I'm not sure. So here, while it zoomed in like this, let's turn on the run stop. So now we're capturing live, right? It's running. You can see it changing. And look how great it looks. So if I go back to that 5 meg, let's just look at that and see. Now, 5 meg, since we're zoomed in, it should look great too, because we're not using deep memory at this point. But if I zoom back out, say at 50 meg samples, and freeze it, zoom in, I'm seeing a little bit more of this stuff going on. So go back out. Okay, make sure okay, so at 50 megaseconds, then go back to deep memory. 100 meg. Oops, I got to have it running, so it switches over. So now it's 100 meg. Okay, now I freeze it again. Okay, now let's zoom in again. Look at that. It's gone. Nice, even square waves. So you want to sample, get lots of samples and use that deep memory. Maybe you don't want to go in auto. Now, if you're just doing general purpose type stuff, then maybe that's fine. Now, you know what? I still not super excited about my square wave down here. So I'm going to turn that on again. I'm going to grab this probe. I'm going to see if I can make it look more square wavy. All right, that looks better to me. That yellow one, it looked like it was off a little bit. Yeah, so that compensation thing's a little bit tricky. It seems simple when you're zoomed out at large, 2 volts or whatever. But see, I'm at 200 millivolts here. The blue one's at 2 volts. Yeah, they're both 10x. Okay, so So a lot of the waveforms are off the screen. It kind of fools me because it shows a yellow line there. But if I try to bring it down, see how it's stretching? So hit the auto set. It puts them both at 2 volts. So I had moved this when I was zooming in, and because we want to see that ripple on the waveform, that deep memory stuff. But we're also using the 12 bits. So that's pretty cool. All right, guys, so I just want to show you something. I've got this at 200 nanoseconds. So I'm catching that edge. It's 500 millivolts, okay? And, you know, I started wondering, like, hey, this 12-bit scope, when I go to maximum mega points, is the bandwidth or the vertical resolution changing from 12 bits back to 8 bits maybe? Maybe that ringing was real. Is it real or not? You always wonder. So you can go back and forth and play, and then you're like, I'm not sure. But comparing it to another scope, maybe it helps you see how that works. So right here, I've got it on automatic, and it's going 5K points. So very few points, okay? But we don't need a lot of deep memory because we're just looking at one edge. But just to prove the point here, so we're at 2.5 gigasamples per second, twice of what we have over there. But we're only collecting 5,000 points across the screen. So see that waveform? Nice and flat, comes up, has a little bit of ripple, and then comes flat, okay? Coming over here, we see the same thing, okay? So now over here, it's like, well, so we're only gathering 5,000 points. So the 12 bits should be fully utilized. I mean, if the memory was taken away from the vertical resolution, okay, for changing the bandwidth, essentially. So now if I go back to here, in this scope, whoops, not normal, right here, instead of auto, I can actually go to max. See, it's got 100 meg, just like the other one, but I can also go to max on this guy, and it'll just max it out. And look at that, 250 megapoints. Waveform never changed. Same. So we can believe that that's what the waveform really looks like. So just gives you a little more confidence that way. Then when we come over here, okay, when we come over here and look at this waveform, sorry about all the reflections, I can come in here and I can go 100 meg. I can drop back down to auto, which is going to go to 2K points. And look, there's maybe the ripple's not as pronounced. Is that true? But the point is it's not bad like what we saw before. So now let me go to 5 meg. It looks about the same to me. Let's max it out. 100 meg. That's good. So that 100 meg points comes in when you're doing this kind of thing. You're looking at a lot of waveforms because you want to see if you see anything funny. You're looking for low frequency type stuff or intermittent issues. Oh, I see something there. I see something here. I see something there. You can zoom in on that portion, but I can capture that, and that's the beauty of deep memory. So I'm coming over here, freezing the waveform, coming back over here and saying, okay, where was that? Was it right? And let's just say it's in the middle for fun. Make it easy. And I can zoom in, and I can go to that 200 nanosecond thing. And look at that. You can see a little bit of digitization, a little bit chunky, if you see what I mean. Just a little bit. But that is incredible. 100 megapoints. We're zoomed out that far, and we can zoom in. So we're at 200 nanoseconds, guys. If I go to 500 nanoseconds, still see a little bit of that digitized chunky stuff, if you know what I mean. You know what? I'm going to zoom in post-editing so you can see that. I'll give it a few seconds so you can really focus on that. Okay, now let's go back out again. And let's see how much time we were doing. Okay, we were doing 50 milliseconds per division right here. Okay, So 50 milliseconds times 1, 2, 3, 4, 8 frames. Okay, so that's 400 milliseconds, almost half a second. So what if I only go to 20 milliseconds, half that many? Let's just do 10 milliseconds. Okay, oops, I gotta start the screen again. I had to re-trigger. Okay, now I'm gonna hit the run stop button. Okay, now let's go back and zoom in on that again. Okay, it's not as digitized. I can see that sinusoidal waveform. Now, if I hit the run stop button, it's going to re-trigger. And see how it's capturing that? So, guys, that's deep memory. Hopefully that made sense. I kind of took some time on that just to try to show you what that looks like. Yeah, deep memory is where I found, when I had my first digital Tektronix scope years ago, I bought one, I was so excited, but I still kept my analog scope. I had a 2430 digital and I had a 2465 analog. I thought I was in heaven. I had both scopes. But then, you know, being in heaven really has one scope that does everything. So anyway, I was so happy to see these new scopes come out with this deep memory. And I remember getting that signal, I think it was 14 mega points for both channels. You'd get 7 mega points per each channel. I thought that was awesome, which it is. That's great. That's better than most of the expensive scopes, and you know, under $2,000, under $3,000 maybe. But 100 mega points per channel, that's nuts. That's just crazy. This costs less than my Signet, and it's so much more scope. Man, we've come a long ways just in half a dozen years. All right, so now I want to show you the FFT. I just think that's such a cool, powerful thing in scopes these days. So let's hit the run stop. Let's capture some waveforms. Let's capture a bunch of waveforms. I'm going to go ahead and hit auto set. Okay, and then we're gonna zoom in on channel 1, I think. So let's set this guy down to zeroize that. Actually, we're going to bring it down a little bit. We're going to turn off channel 2, just get it out of the way. Hit it twice. And then let's amplify this, kind of use the full 12 bits of the screen. Try to get the waveform in there, and we're going to zoom in like this, get lots of waveforms, or zoom out, I mean. That's too many. All right, we're going to zoom out. Okay, now let's hit that FFT. I haven't done it yet. So I can hit this math button and go through this way, or I can hit this little menu button up here. I should show you the menu buttons. And all right, so let's do FFT. There's math, but they set FFT separate, okay? So we're going to turn FFT. We got 2 windows we can turn on. We're going to do one. Okay, turn that guy on, and we're in general mode here. So it's the same GUI as this big scope back here. So we're going to start 0 hertz, and it says end at 78K. We'll end up 1 meg, just to be different. 1 meg. Okay, adjust. Okay. Oh, you know what? Maybe it's because I got so many. Okay, guys, when you have the FFT up here, you need to come over here to the points, how many points you want. If you're only at 8K where it started off, then it only gives you 25K points up here because it's based on your settings. And then that frequency is kind of, I was trying to change this frequency, say 1 meg, and it says adjusted to the limit because I didn't have enough points to get out to that frequency. So if I go to 1 meg, which is a lot of points, now it goes up to 5 mega points up here. So it adjusts that for you, which is super nice. And now I can come in here and it gives those messages telling you what to do. So I go to 1 meg. And so now I can go out to 1 meg, and I got the handing. I got these different windows here that I can do. So I can, you know, right now we're on the handing, fine. And the scale is 20 dB per decade, which is kind of the way I like it. And right there, it's 1.8 dB. So I'm going to put that at 0, enter. Okay, so kind of zeroed it. And then I can go over here to trace, and I can say, hey, let's capture peaks. Let's capture averaging. I can change that to on, or change it to plus minus peak, sample, or average. So you got a bunch of different settings. Now I can go this way to FFT, or I can just hit this gearbox right here once I have the window open. So I can max hold, or I can minimum hold or average hold. So each one of these windows you can kind of set up to what you want. Okay. Whoops, I keep on doing that. Okay, then once you got that set up, you can turn on your markers too. And your markers are the things that are going to pick out the points. So let's say right now I only have one. Let's say if I want to go to 5 points. 5, enter. Okay, and then I have to turn on the, let's see, yeah, turn on the markers right here. So the little table pops up. Say, awesome. And what's so cool, yeah, good. I can move this around. That's so cool because on the older scopes, you couldn't move your windows around. And so right here, you can see what frequencies, and I can see them. They're all highlighted right here at the low frequency end. So I'm going to come in here and change my bandwidth here. Let's go general. So I'm at 0 to 1 meg. Let's go from 0 to 10K, something pretty small. Or, well, we'll go 100K. Okay. And so zoom in on that. And down here it says 0 to 125K. Let's see. Why did it go 125? Oh, it says 100K. Oh, it has to do with my other settings. So it kind of helps me adjust things. So, okay, I could go to RMS and all that, but I think we're good. And it has an auto set too. Let's do that. Let's see what that does. Okay, it goes 50 dB, which I don't want. So I can, oops, hit that one. Bring it back down to 20 dB. But it'll set up your windows. So to put the 0 point and all that. So yeah, most of the noise is these really low frequencies. And we can see that here, 400 hertz, 100 hertz, 1.4 kilohertz. They're kind of alternating positions here. So these FFTs are super powerful these days. Now, something else I want to show you on this. I think, yeah, so see this waterfall? I can't turn it on because I think I have to be limited to, is it 64K? Let's see if it lets me turn it on. Maybe 32K. Well, you know what? Maybe I should just go to 16K and see if that's enough. So, whoops. I got to hit that. Okay, 16K. Oh, there we go. You got to get my big old fingers on those things. So there's the waterfall. So the waterfall's starting to build here. And you can see the points down here, the harmonics. Now we're kind of spread out. We're going out from 0 to 97.6K, it says. And you can see those little points. So we're going to have yellow, you know, I guess it's showing yellow is more, is a heat map, right? So where you're seeing bigger spikes, you're going to get brighter yellows and then dim off to, I guess, green or blue for where there's less energy. But this waterfall is just a way to chart this over time. So you might see a dot here and there, and you're like, oh, that's because I was going to spike every once in a while. So the waterfall is super powerful, super cool that they've added that to these FFTs. The 1 megapoints was the thing that, you know, I saw Signet come out with my first Signet, and then everybody started doing it. And now they've added waterfall, plus they've added all the other spectrum analyzer features. Like the Signet was real pain to set up the FFT, but now you can go start and frequency. That's the range, or I can go bandwidth, and I can go, if I did bandwidth, it's going to say center frequencies 39K and bandwidth 78. So I could put center frequency as say 10K and bandwidth 20K. So that would go, you know, give me a 20 kilohertz bandwidth and put the center at 10. So you can, if you know what frequency of maybe a radio that you're looking at or something, you can center that and get the bandwidth around it. So different ways to set it up. Now 16 points, is that the limit on the waterfall? Yeah, I think so, because these other ones are grayed out. Yeah, so 16K was the limit on that, and then you can see all these points down here. You can see it's like these are like every, like whatever that frequency harmonic is. Yeah, the frequency over here is 937, 2.9, 5, and then 7 almost, and then 9 almost. So it's almost every 2K that you're getting one of these little bumps. So you can kind of see the stripes here. So anyway, there's the waterfall feature and the FFT. All right, that FFT on the job, when I was using the FFT, the Tektronix scopes had a little module you slide in it, and that module probably cost more than the scope. And that was years ago. So this scope does so much more than that module could have thought of done. The waterfall addition is so cool that they've added that. That is such a neat feature. There'll be times, once you start using FFT, now with these new scopes, that signal, I gotta admit, that was kind of a pain in the butt. It was cool that it was there, but it was a pain to use, right? It took a while to set it up. And every time you change the setting, you have to go back and change the other settings. With these, how simple and easy they are to use, I really hope that we all start using FFT more, because you're going to see the power in that. That's just such a powerful tool. All right, so just real quick, I'll just kind of show you some of the features you have here. Now, one thing we've kind of gotten used to is these counters. That's so actually cool that we have counters, automatic counters where you can turn them on. I wonder if I have to turn off my FFT to turn on the counter. Oh, it's on now. So where to put the counter here? So yeah, we got a digital frequency counter. That's really neat. And you can do period. You can, I mean, there's different things you can do with that even. So that's pretty neat. Here, let's turn off the waterfall and the FFT, and I'll get rid of that guy too. Hit the X's. Everything's easy these days. Here's the counter down here, 1 kilohertz. Oops. And so, yeah, everything's looking good there. You know, the other thing is, it's nice to be able to pull up your channel and see all this information with just, you know, with this window here, and then set up everything this way. That is a really cool feature these days. You used to only find that on the real expensive scopes, but nowadays, man, these scopes are so powerful. So we got the counter, and then you also get a voltmeter, right? Turn that on, and here, refresh rate, so how fast it is. The mode is a DC ACRMS. I'll put ACRMS or DC plus ACRMS. I can click on that one. Polarity. So yeah, you got a buzzer. Maybe you want to set up a buzzer in case something happens. So that's pretty cool. So now I've got my counter and my little voltmeter there. So let's see, what is this plus sign? Oh, okay, so then I can set up measurements here too. So what do I want? I can do all kinds of things. Average, peak to peak, just select them like that. And then there they are. So yeah, you got this whole bottom floor that you can put measurements and stuff. And I guess this is probably an update. I'm guessing this is, you know, cycle thing. But if I come back up here, you can see all the, here's histogram. Oh, that's another thing that this scope is real powerful on, is the histogram measurements. Let's see if we can do that. Turn that on. So you can turn on the statistics, and then it gives you all this information here. Samples 5.6, 6,000 hits. Peaks is 6,500 hits. Mean is 40 microseconds. So right here, we don't have a lot of samples. Here, let me go to auto on this. The histogram, that's kind of cool. I'm going to turn it off for now. I'll turn off the stats. Guys, there's so many features on this thing. I mean, you know, I should show you the decode, I guess. Just go real quick. There's RS-232, which is kind of like your UART. Then you got your I2C, the SPI, SPI, and CAN. So there's just so many options. Yeah, and these all come free. You don't have to buy the extra upgrade to get this or that. You got markers. Oh, look, power analyzer. Oh, and by the way, the buttons across here at the top here. So here, if I hit measure, I can do it that way. Or I can hit this guy here. It gives me measurements. Cursors, right? Really nice cursors these days. You can do it that way, or let's see, hit that one right there, gives you the cursors, and analyze. So that gives you your another way to access the power analysis. So say channel 1's your volts, channel 2 is going to be your current. Then it'll know how to do power quality, like you can choose harmonics, inrush current, RDS on. Yeah, guys, this will help you do switching power. This stuff will help you do switching power supplies because it has a way to, you know, knowing your current and voltage, it can tell you RDS on, your switching loss, and slew rate, safe operating area, SOA, modulation, ripple, and turn on and off. So anyway, yeah, power analysis is a cool feature they add with this scope at this price level. That's crazy. So this price level to get those kind of features, that's just nuts. Now, imagine this setup, the time right now it's off. We probably should do auto time. Maybe it has to be set up the internet to do that. I'm not sure, but that is not the right time or anything. I'll set all this up. But yeah, I mean, that's just everything these days on these scopes is so cool. The arrow, there's nothing going on that way. If I had extra stuff, there's left and right arrows on this thing just in case it got too many things here at the bottom. But yeah, if you wanted to set up your trigger, you can go here instead of going over here, and you can just set it up this way. But all the information they give you in one visual cue is so nice versus trying to figure out knobs and watching your screen to see what it does and all that kind of stuff. So pretty sweet. You know, there's your counter, your measurements, your cursors, your pass-fail setup if you want to do that. The other thing is, what was I going to show you? The record mode, so you can record your screen, record information. I mean, you can always do the picture thing, right? Where you're just saving pictures. And I think that's this one right here, quick. So you just hit this to give you a picture real quick. But you can do a video recording of your screen as well. So if you're trying to, you know, show somebody what you found or what you're looking at and pass that information on, it makes it so much easier. Yeah, there's just so many things to show you on the scope. Hopefully, I tried to point out some of the really powerful features, but the persistence, you know, some of the other functions they have, the histogram, the persistent stuff, the decoding. Someday we'll have to do a video on that. I need to do more videos on each one of these kind of functions. The GUI, the interface is just like its big brother, so it makes it easy to go from one scope to another because they work pretty much the same. There might be some different options. Like this one had the max mega points, where this one just said, you know, you can just select it. But yeah, pretty cool scope. So what do you guys think? All right, guys. So 2 big thumbs up to Uni-T for sending this out. Amazing scope. Just awesome. I mean, it's 2-channel. The price on it, let's talk about the price. It is. All right, guys, let me run down some prices. This guy here, 150 megahertz, is $439. That's nuts. That's a great price. Now that's list prices. Just come out. You want to wait 6 months, a year? Who knows? There'll be some sales. But $439, that's pretty crazy. But here's the thing: for the same price, you have 4 channels. Just drop down to 80 megahertz. 80 megahertz, man, that's still plenty fast, guys. So, okay, if you want to drop down in price a little bit, you go the 2-channel 80 meg for $329. I mean, I just think these prices are crazy. So $549 for the 4-channel version of this. So another $110, you get 2 more channels. But I mean, percentage-wise increase, that's fairly significant. That's like 25% more. Same price for 4-channel 80 meg. Man, for me, like, you know, if I was trying to be on a budget, I'd go for that 80 meg 4-channel. Now, honestly, I mean, I do use more than 2 channels often enough that I'd want the 4-channel, but I could get by with 2 channels. I got by Signet 2-channel for a while, and it wasn't like it was an effort to get by with it. Most things I'm doing is one channel or 2 channels. If you're trying to compare signals with each other, you can use 1 channel as your reference, say channel 1, and move channel 2 around to look at your other signals. Might take you a little bit extra time, but if you feel like you need 150 meg, first ask yourself why. What is it that you're looking at that needs 150 meg? This bad boy is 500 meg. Going from, 80 meg to 500 meg, that's significant, but going from 80 to 150, yeah, it's double, but still, it's, I'm trying to think of the kind of things you'd be looking at that matter. So I don't know. We saw the rise time of that clock signal, and we zoomed in. It was 20 nanoseconds we're looking at. That's a very small time frame. That's very small, and I could have gotten closer, I think. I just stopped at 20 because I saw the waveform I wanted. But we compared that to the 500 meg scope, and they looked almost like, they looked identical as far as I could tell. So anyway, there you go. Prices, Black Friday sales. Check out Uni-T. They got a lot of stuff on sale. Oh man, they've got some scopes that are like, especially if you're not looking at the 12-bit ones, if you're looking at some of the scopes that came out last year, man, some great prices. Or generators, all those kind of things. Multimeters, they've got some really nice meters. Man, they're just doing a really good job. This UT171C back here, and just a sweet meter. So, yeah, they've got some really nice clamp meters that you've seen in some of my short videos, maybe. I've showed a preview of some of the meters they sent me just recently. So, yeah, 2 big thumbs up to Uni-T. 2 big thumbs up to my YouTube members and my Patreons, and Danny for being a team member of YouTube. That's awesome. Thanks, guys. No one's hit that super thank you button down there for a while. So if I'm saving you money, showing you something cool, maybe buy me a cup of coffee. You don't have to do that. Just hit the thumbs up button. That's all you need. That's what I asked for. Okay, subscribing. I love that too. Grow the channel. Let's do it. God, I got so many toys, so many things to do, so many projects. I could do this full time and still not have enough time to do everything. But as it is, I have a day job because about 70-80% of you guys are not subscribers. So anyway, thanks for watching, guys. I really appreciate you sticking out this long. Give yourself 2 big thumbs up. Yeah, thanks for supporting me and watching the channel. Hitting the thumbs up. And happy Thanksgiving. This is Black Friday today. I'm going to get this video out today. So, enough talking. We'll see you next time.